Hello friends, welcome to today's video. Today I'll talk about analysis of BRIX, POL and purity of pan flour materials in sugar industry. Examples of pan flour materials are syrup, massecutes and molasses. The principle of analyzing BRIX, POL and purity in pan flour materials is same as that of juice samples. Remember, examples of juice samples are fast expressed juice, mixed juice and clear juice. However, sample preparation and calculations of pan flour materials is different from that of juice samples. I therefore recommend that you first watch a video I uploaded on how to determine BRIX, POL and purity of juice extracted from sugarcane, just in case you didn't watch. Then proceed to this one so that you can get the whole concept of BRIX, POL and purity analysis. POL is the apparent sucrose content in a solution. In other words, is the amount of table sugar in a solution, determined by polarization method. BRIX is a measure of total dissolved solids in a solution. Examples of total dissolved solids are minerals, reducing sugars, and sucrose. This can be analyzed by refractometer or hydrometer. And purity is the percent proportion of POL in the BRIX. So purity is equals to POL over BRIX times 100%. The main aims of BRIX and POL analysis are: number one is to determine the efficiency of heating vessels. Examples of heating vessels are evaporators and pan boiling vessels. Remember, for sucrose to form sugar crystals, extracted juice has to be concentrated to supersaturation point. So if syrup is underboiled, no or less crystals will be formed. Number two is to ensure that massecutes attain the required BRIX for efficient separation in the centrifuge. Remember, if massecutes are loose, most sugar crystals formed will be lost to the molasses. Number three is to ensure that materials do not over-BRIX for easy pumping and prevent blockage of pumps. Number four is to ensure that there is maximum exhaustion of sucrose from syrup and molasses. And finally, is to ensure that there is minimum sucrose loss through final molasses and caramelization. Elements for this analysis are: number one, have samples. Under samples, we have syrup and melt. Next, we have massecutes. Examples of massecutes, we have massecute A, massecute B and C. Next, we have A heavy molasses. Next, A light molasses. Next, B molasses. Next, final molasses. If you want to know how these materials are formed at pan boiling section, I request you to watch a video I uploaded on pan boiling and centrifugation. The next requirement is weighing scale. Next, polarimeter, measuring cylinder. Next, refractometer. Next, spatulas. Next, lead acetate. Next, distilled water. Next, 250 ml beakers. Next, 200 ml volumetric flasks. Next, rods. Next, funnels, and finally, filter papers. See the procedure of determining BRIX in our samples. Number one, measure 100 grams of the sample and pour in 1 liter jug. Add 500 grams of water. Dissolve the sample completely by stirring with the rod. Stand the diluted solution in a running cold water bath until the solution cools to room temperature. Read the BRIX of diluted solution using the refractometer. Kindly allow me to refer you to my previous video on analyzing BRIX, POL and purity of extracted juice. In that video, I have described how to use the refractometer to measure BRIX of a solution. Let's cover procedure for POL reading. Measure 52 grams of the 1:5 solution prepared and pour in 200 ml volumetric flask. Top up to the mark with distilled water. Pour this solution in 250 ml beaker. Add 2 spatula of lead acetate and stir thoroughly to mix. Fold the filter paper and place in the funnel. Place the funnel on top of Conco flask, then pour the sample in the funnel. Discard the first 20 ml of the filtrate. Collect the remaining filtrate and read its POL using polarimeter. I again refer you to my previous video on analyzing BRIX, POL, and purity of extracted juice. In that video, I have described how to use the polarimeter to measure POL of a solution. In juice samples, we were recording the reading gotten from the refractometer directly as BRIX of juice samples. But for pan flow materials, we must multiply the reading recorded from refractometer with dilution factor. Remember, pan flow materials are diluted before BRIX reading, but juice samples are not diluted. So for our case, the dilution factor is 6. This because we mixed 100 grams of the sample with 500 grams of distilled water. So our ratio was 1:5. So total ratio will be 1 plus 5, which is 6. So 6 is our dilution factor. So to get the exact BRIX of our sample, you take BRIX red times 6. So for example, the BRIX red of a massecute was 15. You will take 15 times 6, which is equals to 90. So the exact BRIX of massecute is 90. You can remember, we were using tables to correct POL of juice samples read from polarimeter. But for pan flow materials, we do not use tables, but we multiply POL read from polarimeter by dilution factor to get exact POL. So exact POL or corrected POL is equals to POL read times 6. Remember, for our case, the dilution factor is 6. And purity is equals to POL over BRIX times 100. Below is an example. The BRIX and POL of final molasses red is 13.3 and 4.37 respectively. Calculate the actual BRIX, POL, and purity of final molasses. To get the actual BRIX of final molasses, you take 13.3 times dilution factor, which is 6, is equals to 79.8. So the BRIX of final molasses is 79.8. To get the actual POL of final molasses, you take the POL red, that is 4.37, times dilution factor, which is 6, is equals to 26.22. So the actual POL of final molasses is 26.22. So to get the purity of final molasses, you take actual POL, which is 26.22, over actual BRIX, which is 79.8, times 100 is equals to 32.86. So the purity of our final molasses is 32.86. Below are the critical limits for each sample. Number 1, you have syrup. For efficient crystallization at pan boiling section, BRIX of syrup should be maintained between 55 to 60. BRIX below 55 will force pan boilers to take more time to concentrate syrup, which will lead to time-consuming and caramelization of syrup. While BRIX above 60 may lead to false grains, which can block last evaporators tubes. These false grains can also lead to formation of poor quality sugar grains. Purity of syrup depends on maturity of sugarcane being made. It also depends on how extracted juice has been handled from milling to evaporation section. So if mature cane is milled, the expected purity of syrup is above 83. The BRIXs of massecute A, B, and C are between 90 to 93, 93 to 96, and 96 to 98 respectively. This BRIX has to be maintained in this level to ensure efficient separation of sugar crystals. Corrective measures for syrup and massecutes in case their BRIXs go beyond the set limits are to remove scales from tubes. Remember, scales can prevent efficient flow of heat from outside to the material. Next is to control the flow of feeding material. And finally is to control the supply of pressure and steam. BRIX of A heavy molasses has to be between 77 to 81. BRIX of A light molasses has to be between 76 to 80. BRIX of B heavy molasses has to be between 79 to 82. And finally, half final molasses has to be between 80 to 85. If the BRIX of A light, B heavy and final molasses is below 74, it shows that a lot of water is being added to MASSECUITES during centrifugation. These low BRIX lead to high purity in molasses, since most crystals are washed away to molasses. After the first crystallization and centrifugation, it is expected that the purity drops by 15. That's why A MASSECUITE, if it has 83, A heavy and A light molasses will have BRIX of purity of around 68. And the purity of A heavy and A light is somehow related to B MASSECUITE because A heavy and A light molasses are the one used to prepare B MASSECUITE. And after the second crystallization and centrifugation, we expect purity drop of around 20. That's why B MASSECUITE has around 68 to 73 purity and B heavy molasses has around 48 to 53. And you can see B heavy molasses purity is somehow related to C MASSECUITE. This because B heavy molasses is used to prepare C MASSECUITE. Again, after the third crystallization and centrifugation, we expect purity drop of around 20. That's why if C MASSECUITE has 49, the final molasses purity, if this material has been centrifuged well, the expected purity is between 29 to 33. So if in case you analyze final molasses and find that purity is above 33, it shows that centrifugation of C MASSECUITE has not been efficient. And it also shows that a lot of sucrose is being lost to molasses. BRIX of pan flow materials has to be closely monitored to ensure that there are no unnecessary plant stoppages that are caused by slow movement of materials or blockage of pumps. It's also important to monitor purity drop in MASSECUITES to ensure that final molasses has minimum sucrose which cannot be further recovered. Remember, at pan boiling section, our aim is to extract as much sucrose as possible. Thank you very much for watching my video. One of our members really wanted to know how to analyze BRIX, POL and purity of pan flow materials. I believe this video will benefit him and all other viewers. See you in the next video.